just simply a piece of wire, right? But in RF system, any cable or wire with physical length greater than the wavelength of a signal passing through this wire is called transmission line. Actually, we have discussed this point earlier, right? Whenever frequency increases at high frequency, the physical length becomes larger than the wavelength. For example, if we are considering 3 gigahertz versus 30 gigahertz, or else 3 kilohertz versus the 30 gigahertz, there the device length becomes very larger than wavelength. So if any component passes signal, or if any piece of wire allows the signal which has smaller wavelength than its length, then that line is said to be what? Transmission line. Okay, one of the best example of transmission line is coaxial cable. So all of you might have seen this coaxial cable in your cable TV, right? So coaxial cable has inner conductor, outer conductor, right? In between inner and outer conductor there is an insulation. Here they are using polyethylene, Teflon. Many things are used for coaxial insulation. The most common transmission line used in RF transmission is the coaxial cable for R. Also it is called as coax. Okay, here you can see the equivalent circuit of transmission line. Okay, electrically we can define transmission line as a network of resistor, inductors and capacitor as shown in the figure, right? So almost in a transmission line measurement we are considering an element as one length. If we are measuring resistance, for example, we will say 2 kilo ohm per unit length. If we are measuring capacitance, we will say 20 microfarad per unit length, or else if we are for inductance 50 millihenry per unit length. So in high frequencies we will mention the value of particular resistance, capacitance with unit length, with length of the element also, right? Next one, impedance matching. So why impedance matching is necessary? Here you can see we are having a source, right, that generates some signal. The signal is passed through this transmission line. Also the total power is delivered to load ZL, right? Total power is delivered to load ZL. For example, you can consider this as your power supply. This will be your connecting wires at home. This will be your fan, regular fan, right? So once power supply is generated here, right? Once power supply is generated here, it will travel through this equipment. So what if we don't have this in between component? If you are directly connecting the load to power supply, we will achieve maximum power transfer, 100% power transfer, right? But that is not practically possible. So that we are using in between components. So this in between components doesn't reduce the source power larger. That is our whole idea. So in high frequencies, what will happen whenever the signal passes through this transmission line components, or else this resistor, the signal will be time delayed. The signal will be time delayed, as well as for an AC signal, phase shift will occur. Means complex reactive part dominates. More than resistance, reactive part dominates. We have to nullify that reactance part, right? So impedance is a complex quantity, whereas resistance is real number, R is real number, but impedance is complex number, R plus JXL, right? R plus JX. So here we have to remove that reactive component first. We have to eliminate that JXL. To remove plus JX, R plus JX, to remove plus JX, you can use minus JX, opposite reactance, right? So after eliminating the reactance, then we have to match resistance. This process is called what? Impedance matching. So at any point of time, the source and load impedance should be same, or else if you are looking towards this side, from this point, if you are looking towards source side, the impedance should be Z0. From source side, if you are looking towards load, whatever may be the components following after this point, that doesn't matter, right? If you are looking towards this transmission line, the throughout impedance of the following circuit should be Z0, right? So by overall, or else simply I can say that at any instant of time, at any point of the circuit, the characteristic impedance value is 50 ohm, right? The impedance and the total circuit should have the value of 50 ohm. So why they are fixing it as a 50 ohm, that story and all I will tell you later. The characteristic impedance value is 50 ohm. I can tell you one more simple example with the high frequency. Consider that you are having a function generator here, you are having a CRO here, right? You are using probe in between. The one end of the probe plus output port of the function generator should be matched. Means this output port of the function generator is 50 ohm, one end of the probe is also 50 ohm. Here also the same, other end of the probe, that connector as well as port of the CRO, end of the connector, both should be what? 50 ohm. Then only the signal what is generated here will reach load, nothing but CRO here. Simple example. This is a simple example, right? So to achieve maximum power transfer in high frequency circuit, we definitely do impedance matching. So we will see one experiment using transmission line in next video.